Hello everyone, today we are going to start lecture 04 of class 8 mathematics chapter number 1, which is rational numbers. In this lecture we are going to study about multiplication of rational numbers and properties of multiplication of rational numbers. So let us start by defining what is multiplication of rational numbers. It simply states that if a upon b and c upon d are two rational numbers, are two rationals or rational numbers. You can also write them as rational numbers. Rational numbers, then a upon b multiplied by c upon d simply says a cross c all upon b cross d. That is, you have to multiply numerator separately and you have to multiply denominator separately. So this is the easiest way of multiplication of rational numbers. Also, in this multiplication, if anything from the numerator part portion and denominator portion gets cancelled, then you can cancel them. That is, you can make this number in the simplest form by cancelling out the common factors from numerator and denominator, just like you do in the normal fraction. So multiplication of rational number is defined where you have to multiply numerators and denominators separately. Okay, let me give an example to explain how it works. Let us multiply 3 upon 4 by 5 upon 7. See, these both are rational numbers. So according to this method, it will be 3 into 5 whole upon 4 into 7, which will give us 15 upon 28. Right? 7 into 4 is not 21, it is 28. So 15 upon 28. I hope it is pretty clear. Now clearly in this particular question we do not have anything to cancel, so we cannot do that. But let us take another example in which there is something to be cancelled. So we can have minus 36 upon 7 into minus 28 upon 9. Then again you have the same point, minus 36 into minus 28 whole upon 7 into 9. So you can cancel out it by minus 4 times, because 9 into 4 is 36. You can also cancel out this minus 4 times, as 7 into 4 equals to 28, and you will get plus 16 as the final answer. So this is how you can cancel out the common factors during multiplication, which makes the question easier. I hope it is clear. Okay. You can also do the exact multiplication of 36 and 28, which would give you 1008, and you can multiply 9 into 7, get 63, and then you can divide the final result by 63. Then also you will get 16. But if you do it in the process of multiplication, then it will keep the fractions low and multiplication easier. Okay. Now let us move towards a question to understand this further. The question is, simplify minus 16 upon 5 into 20 upon 18 minus 15 upon 5 into minus 35 by 3. So we will simplify this. First of all, we will multiply these two. So we will get minus 16 into 20 whole upon 5 into 8 minus. Here we will get 15 into minus 35 whole upon 5 into 3. So we can cancel out 20 4 times, and we can cancel out 16 2 times. Similarly, we can cancel out minus 35 minus 7 times, and we can cancel out 15 by 5 times, because 3 into 5 equals to 15. So we will get here minus 8 minus 7 into minus 7, 5 into minus 7 equals to minus 35. So you will get minus 8 plus 35, which is equals to 27. So this is how you can carry out a simplification of an expression on the basis of multiplication of rational numbers. In multiplication of rational number, the easiest part is that you can cancel out the common factors from numerator and denominator, and it will help you find the answer easily. Let us take another question which involves 3 terms. This question involved 2 terms. Let us say another question which involved 3 terms. Simplify minus 3 upon 2 into 4 by 5 plus 9 by 5 into minus 10 by 3 minus 1 by 2 into 3 by 4. So let us do that. Let us multiply all the numerators and denominators of fractions. Minus 3 upon 4 whole upon 2 into 5 plus 9 into minus 10 whole upon 5 into 3 minus 1 into 3 whole upon 2 into 4. Okay. So this is how you have to multiply. Now you can see for some common factors, you can multiply this. Okay, so you can cancel out 4 2 times. So here you will get minus 3 into 2 equals to minus 6 whole upon 5. You can multiply minus 10 by 5, you will get minus 2. So here you will get minus 18 upon 3. Okay, minus you will get 3 upon 8. Now you can easily solve these 3 rational numbers by taking the LCM of 5, 3 and 8 all at once. Either you can add firstly 5 and 3, say minus 6 upon 5 and minus 18 by 3, that one, or you can add minus 18 by 3 or minus 3 by 8, or you can add the 5 1 and the 8 1 terms. But you can add all 3 together by taking their LCM. Now let us take the LCM of 5, 3 and 8. Let us take the LCM of 5, 3 and 8. And you can find, since 5, 3 and 8 are co-prime numbers, their LCM is their product only. So 3 you can also take as 2. Okay, prime factorization should be start from 2, but I am doing this to tell you that you can start with any factor. It does not matter that what is the factor you use. You can also keep it like this. See, and then 5. Had you started with 2, then also you have to multiply it by 3. Okay, now you have started with 3, then also you have to use 2. So LCM is simply 3 into 2 into 2 into 2 into 5 is equals to 3 into 8 into 5. That is, LCM should be how much? LCM should be 8 into 5, 40 into 3, 120. Now again, you can clearly see 120 is the LCM only because I have not cancelled the common factor 3 and 18. Again, why I am doing so? To tell you that if it affects the answer or not. Okay, obviously it will not affect the answer because it will cancel out in the further question. But for the time being, I am not cancelling it out, right? You can cancel 3 with minus 18 by minus 6 times, but I am not doing so. Let us take it to the LCM and see if it affects the question or not, so that it will create an effect in your mind that you can carry out multiplication till end, or you can do it in between, and see what makes it easier. Had you cancelled 3 and minus 18 with the common number 3, your LCM would become so easy. It would be simply be 8 by 8 into 5, that is 40. So it would become easy. That is why I stress on cancelling out the common factors in between multiplication. For the time being, we do not do that. So 5 into 24 equals to 120. So 6 into 24 is what? 6 into 24 is 144. Right? 3 into 40 is equals to 120. 3 into 40. You have to multiply 3 by 40. So you have to multiply 18 by also with 40. So 18 into 4 is 72. So you will get minus 720. 8 into 15 is 120. So 3 into 15 is equals to 45. So this is how we will calculate the answer. Now let us add these 3 numbers. So 700 plus 100, 800. 820, 865, 865 and 40. So it is 905 and 909. So you will get minus 909 all upon 120. Now you can cancel out the common factor, which is 3. So you will divide numerator and denominator by 3. So you will get minus 303 all upon 40, which is the final answer. See, you have not cancelled out the common factors here, so you have to do it there. Okay, again the common factor was 3, and here also the common factor was 3. So no matter where do you keep the common factor, but see, since you did not cancel it out, you will get a large figure. It would become very hard to do in the exam. So you should be able to do it in the steps so as to avoid very large numbers, right? So it was very easy. Now let us move on towards the properties of multiplication of rational numbers. The first property is closure property. We have already studied closure property for addition and subtraction. This closure property of multiplication of rational numbers simply states that if A upon B and C upon D are two rational numbers, comma, then A upon B cross C upon D will also be a rational number. Simple. So if A upon B and C upon D are two rational numbers, then A by B and C by D will also be a rational numbers. Okay. Let me give you an example. It is very easy. It is very clear that yes, if you multiply two rational number, you will always get a rational number, because the multiplication is A cross C upon B cross D, which is essentially a rational number, right? Now let me give you some examples to make it more clear. Let us multiply 3 by 2 into and 5 by 7. So 3 by 2 into 5 by 7, and we will get 3 into 5 upon 2 into 7. So the answer would be 15 upon 14. Again, it is a rational number. You can also multiply even 0 with, let's say, 7 upon 8. And here it is nothing, so we can write it as 1. So it would be 0 into 7 whole upon 1 into 8, which is nothing but 0 upon 8, which is again 0. So you can see product of two rational numbers will always be a rational number. So it is a very easy property. Let us see the next property, which is commutativity. It simply states that if A upon B and C upon D are two rational numbers, then A upon B cross C upon D is equals to C upon D cross A upon B. So commutative property simply states that you can multiply two rational numbers in any order. Let it be A upon B cross C upon D or C upon D cross A upon B, and you will get the same result. That is, multiplication of rational numbers is commutative, just like the addition. Okay, now let us again see some example. Without example we cannot verify it. Okay, let us multiply 3 upon 4 and 5 upon 7. So in this order we will get 3 into 5 whole upon 4 into 7. That is 15 upon 28. Now let us multiply 5 upon 7 into 3 upon 4. So we will have clearly, you can see By reversing the order of multiplication, the answer remains the same. So, multiplication of rational number is commutative. It is very easy, right? Let us move to the next property, which is associativity. Now, what it says the same thing as commutativity, but for three numbers. If A upon B, comma, C upon D, and E upon F are three rational numbers, comma, then E upon B cross C upon D into E upon F is equals to E upon B cross C upon D into E upon F, which simply means that if you multiply A upon B and C upon D first and then multiply the result with E upon F, you will get an answer. If you multiply C upon D into E upon F first and then multiply it to A upon B, then also we will get an answer, and then both the answers would be same. It is no matter which two numbers you multiply first, the final product will always be same. Okay, it is very easy. Let us verify it. For the sake of simplicity, let me take an example of integers just to tell you what the associativity is, and then we can take the example of rational numbers. Example. For three integers, let us take firstly for integers. For three integers, comma, -5, 2, 3, -5 into 2 into 3, where we multiply them first is equals to -10 into 3 equals to -30. Now if we multiply same three numbers and now I multiply them first, then we will have -5 into 6, which is again -30. Okay, this is the associativity for integers. Let us verify for rational numbers, actual numbers which have some denominators, right? These are also rational numbers. That is why I am using this property in integers also. Okay, so I am trying to tell you how to use this property to verify. Let us take another example which have some fraction. Let us multiply -5 by 4, -6 by 11, and 2 by 7. Let us multiply these both together. Then we will have -5 by 4 into 6, -6 into 2 equals to -12, whole upon 11 into 7 equals to 77. Multiplying this together, we will get -5 into -12, whole upon 4 into 77. Multiplying it by -12, we will get -3. -5 into -3 would be +15, whole upon 77. So this is the product. Now let us multiply it like this. So we will have -5 into -6 whole upon 4 into 11. We can cancel out it with the common factors. Okay, we will have -5 into 3, that is 15, whole upon 2 into 11 equals to 22. Again it is 2 by 7. So we will have 15 into 2 whole upon 22 into 7, right? You can divide it by 2 and you will get the answer as 15 upon 77. So this is the final answer, and you can see that using associativity of rational number you can get the same result even when multiplying different kind of numbers together, right? In the first we have multiplied -6 by 11 and 2 by 7 together, and in the second part we have multiplied -5 by 4 and -6 by 11 together. Okay, This was all about associativity. Now let us move to the next topic, which is existence of multiplicative identity. Right. Let us move to the next topic, which is existence of multiplicative identity. Let us find out what is multiplicative identity. We know additive identity for a rational number is 0. That is, if you add 0 to any rational number, it would not change it, and the rational number comes itself. Similarly, in the multiplicative identity, if a upon b is any rational number, comma, then a upon b into 1 is equals to a upon b is equals to 1 into a upon b. Right, where 1 is called the multiplicative, identity for rational numbers. Now, why 1 is called multiplicative identity for rational numbers? Because if you multiply 1 with any rational number, it is giving you the same rational number. So this is the multiplicative identity of rational numbers. Okay, so this was the existence of multiplicative identity. Now let us move to the next topic, which is multiplication by 0. So multiplication by 0 simply means that every rational number when multiplied by 0 will give the result 0. Okay. So what does multiplication by 0 simply means? That if a upon b is a rational number, comma, then a upon b cross 0 is equals to 0, which is equals to 0 cross a upon b, because multiplication of rational numbers are commutative, right? So you can clearly see that if you multiply 0 with any rational number, you will always get 0. So this was multiplication of a rational number by 0. It is not a very big property, but you can understand that. Example, if you multiply 5 upon 7 by 0, you will get 5 into 0 whole upon 7 into 1, and you will get 0 upon 7, which is equals to 0. So it is the similar property. Okay, we have already done this in the questions. So let us move on to the next property, which is a bit important, which is distributivity of multiplication over addition, right? That is, it states if a upon b, c upon d, and e upon f are rational numbers, then a upon b cross c upon d plus e upon f is equals to, that is, multiplication will be get distributed over addition. So see, a upon b cross c upon d plus a upon b cross e upon f. That is, you can simply distribute. See, multiplication got distributed, okay, over addition. So firstly, a upon b is multiplied by c by d plus a upon b is multiplied by e upon f. So that is what we call distributivity of multiplication over addition. You can verify it with the help of an example. Let us multiply 2 upon 3 with minus 3 upon 5 plus 7 upon 10. So firstly, let us use this multiplication method. So we will go like this: 2 by 3 minus 3 upon 5 plus 2 by 3 into 7 upon 10. So that will be, we'll cancel out 3 and 3 as the common factors, and we'll get minus 2 upon 5, right? And here we will cancel out 2 to 10 with 5 times, and we will get 7 whole upon. So what we have done? We have done this like this, and we have did like this. Okay, so we got 7 upon 15. Now if we are taking the LCM, we will get 5 into 3 equals to 15. So minus 2 into 3 is equals to minus 6, plus 7 is equals to 1 upon 15 as the product. Now let us find out the conventional way. That is, firstly let us add the numbers within the bracket and then multiply it with the final product. So again, taking the LCM, you will get 5 into 2 equals to 10. So minus 3 into 2 equals to minus 6, plus 7, right? We will get 2 upon 3 into, it will be 1 upon 10. So it will be 1 upon 15. You can clearly see that either way you get the same answer, but you can clearly see that multiplication gets distributed over addition. That was the actual property. Okay, let us move on to the next property, which simply states the existence of multiplicative inverse or reciprocal. We have already seen the additive inverse, which is nothing but the negative of a rational number. Similarly, multiplicative inverse is nothing but the reciprocal of the rational number. So what does it state? It is a very easy property. It simply states that for every rational number non-zero. Why are we writing non-zero? We are creating a condition that every non-zero rational number, that is whatever we are writing is true for a rational number which is non-zero, that is a rational number should not be zero. I will tell you why we are writing this condition. For every rational number which is non-zero, or you can write it as for every non-zero rational number a by b, comma, there exists a rational number C upon D such that A upon B into C upon D is equals to 1 is equals to C upon D into A upon B. So for every non-zero rational number A upon B, you will have another rational number such that product of both the rational number is 1. Now what is 1? 1 is multiplicative identity. So in this case, if C by D is a number such that product of these two numbers either way is 1, then you can call A upon B as multiplicative inverse of C upon D and vice versa. Then, comma, A upon B is called the additive inverse of C upon D, that is A upon B is reciprocal of C upon D, that is C upon D whole inverse. Okay, and C upon D is called the additive inverse or reciprocal. It's called the additive inverse, or you can say reciprocal of A upon B, that is C upon D is nothing but inverse of A upon B. So this is how we define multiplicative inverse or reciprocal. So reciprocal of a number is nothing but the interchangement of denominator and numerator. Okay, clearly you can see that A upon B is equal to C by D whole inverse. Now what is reciprocal? Nothing but D upon C. So this is reciprocal. Now let me show you how you can find reciprocal of a rational number. You can use the same property. This is the symbol for therefore. Okay, these three dots represent therefore. Therefore, you can say that if a by b is a rational number, if a by b is a rational number, comma, then the only condition to find reciprocal is that a number whose product with a by b should be 1. So let us choose that number with b upon a. You can clearly verify that it is 1. Also, if you multiply b by a into a by b, and you will also get 1. So you can see we are getting the same condition as we are getting with c by d. When we multiplied a by b into c by d and we got 1, we said that they both are reciprocals of each other. So here also we are multiplying a by b with just reciprocal of it, that is b by a, and we are still getting 1. So it implies that b by a is additive and multiplicative inverse or reciprocal of a by b. B by a is multiplicative inverse or reciprocal of a by b, which simply state that b by a is a by b inverse. Of course, a by b is also b by a inverse. Okay, so you can write it as a by b is equals to b by a inverse. So this was existence of multiplicative inverse or reciprocal. Now if you combine these both situations, that is b by a equals to a by b whole inverse and a by b is equals to b by a whole inverse, you will get that a by b whole inverse is b by a, and if you do again whole inverse of this number, you will again get a by b. See, a by b whole inverse is b by a, and if you do b by a whole inverse, then you will again get a by b, that is a by b. Inverse of a inverse is nothing but the same number. Okay, so reciprocal of a by b is b by a, then again reciprocal of b by a is again a by b. In other words, reciprocal of the reciprocal of a rational number is the number itself. Clear? Let me show you some important points about multiplicative inverse. First point is that reciprocal of 1 is 1 and reciprocal of -1 is -1. That is, 1 is the reciprocal of itself, it is pretty clear, and -1 is the reciprocal of itself, it is very clear. And these are the only two rational numbers, -1 also, comma 1 and -1, that is, these both are the only rational numbers, which are reciprocals of each other. Sorry, which are reciprocal of itself. It will not be correct to write each other, which are reciprocal of themselves. So you can see 1 and -1 are the only rational numbers which are reciprocals of themselves. That is, if you try to find out the reciprocal of 1, it will be 1, and if you find out reciprocal of -1, it will be -1. They both are reciprocals of themselves. Second important point, it is a bit important that 0 has no reciprocal. 0 has no reciprocal. Why? Because you can find no number no number which when multiplied by 0 will give 1. You can write the reason as because there is no number which when multiplied by 0 gives 1. Okay, so we do not have any number. Let it be x. Let the number be x. If you multiply 0 with x, you all know that you will not get 1. Therefore, x do not exist. That is why we have said in the definition portion that a rational number should be non-zero. That is, a by b should be non-zero rational number. Then only its multiplicative inverse will exist. So this was all about multiplication of rational numbers, their properties, how to find multiplicative inverse. Okay, what is multiplicative inverse? How to carry out multiplication using distributivity laws, and all about multiplication. I hope you got the lecture. Let us see you in the next lecture. Till then, thank you. Goodbye.